Okay, so this video is going to be a little bit different for a couple of reasons. One, I'm not at home. It is Rosh Hashanah this weekend, and I married into a Jewish family. So my mother and father-in-law, they live Boca Raton area, so like near Miami. Then sister-in-law and her husband live in actual Miami, and we live, of course, in the Atlanta area. So it's been a while, but wanted to be able to spend part of the holiday with them. And so we drove down to Ormond Beach, right by Daytona Beach, and they drove up. Everybody finished getting here yesterday. The sister in law and her husband got here late last night. But this way, we're all here for the holiday. Rosh Hashanah is pretty much the Jewish New Year, and very apropos for this year, considering basically make amends, whatnot, for the previous year, and then bring in the new year, bring it in fresh. So, considering how crazy this year has been so far, let's hope bringing it in fresh goes really well. Because of this, I am not going to be responding to stuff as quickly. While I may not be Orthodox Jewish, my in laws are, and I try to show as much respect as possible. So I'm going to be spending a lot of time with them. There will not be electronics. I won't be checking email or any of that stuff. So my apologies if anybody sent me anything and it took me a while to get back. But if you watch this video, you will then understand that's why I wasn't responding right away. It's family time, you know? But because of that, I get to be at a beach and I'm so happy about it. And it's funny because I was testing the camera earlier and I'm like, all depending on where I move to as to the lighting, but it's pretty cool. So anyway, I know people have trouble with this lab, so I've made some slight adjustments. This part one is now open until the end of this week. You should have been busting butt to do it earlier this week. As of the moment of me making this on Friday, only 8 people have turned it in. 8. I made an announcement about it, told everybody exactly what to do to request any extra time. So far, no one has actually done what I said in the announcement. Not even one person. I have had emails of, oh my gosh, this is horrible. Oh my gosh, I need more time. Not one person has actually done what I requested in the actual announcement, unless they put it's one of the 8 people who have turned it in. That's possible. I haven't opened those yet. But this happens every single semester. I started off very strict with the energy consumption part 1 like that, trying to get you to not waste your time. Every single semester I end up having to extend it, but I have to scare the crap out of you first. That's why I've responded the way I have, because part of doing schoolwork is learning proper time management. Time management does not mean having enough time to knock everything out. It means managing the time you have in order to knock everything out. So you cannot just do this and then expect to slap everything out in one day. Especially not if you have multiple classes. It does not work that way. It means literally saying, okay, I can take half an hour this day. I can take half an hour this day. Oh, this day's very busy. Okay, 15 minutes I can work on this, 15 minutes I can work on that kind of thing. These labs, while they do look intensive, really don't take as much time as you think if you just do literally what you're told to do. Don't panic. That's a big one. Don't just skim over the words and think you can figure it out, and don't just try to Google the answers. If you actually read what I tell you to do and watch the videos where I show you exactly what to do, they're really not that bad. I just redid all 3 labs this morning. This morning, it's only 11:42 a.m. You can see my screen, but I already redid them all. I have my notes from doing it. I'm doing it for details of the location I'm in, so I'm not even using old school stuff for part 1. All of it I just redid, and I am about to record how to do it. I'm even going to do the calculations for you and talk every single step through. So if after this you tell me that you just don't have enough time to get it done, it's really based on you deciding it's not important enough for you to sit down for 30 minutes to an hour to actually work on. If you don't have 30 minutes to an hour to work on an assignment for a course, then you probably shouldn't be taking the course. That's not meant to be cold, it's just truthful, because if you can't put the time into your class, you're not getting anything from it anyway. It's a waste of your money. Don't waste your money. Yeah, that's pretty much it. So I have these new documents listed here. This should look like the one you already have where it talks about energy consumption 1. Scroll through here. I'm going right past what you need. I'm going straight to the procedure. So, heat loss / gain through windows. This first part is just talking why you're doing this and what it means. If you read it, that's not a bad idea. I would recommend it, but I'm just going to skip on down to here. This highlighted part. This is one of the things that gets a lot of people freaked out because they see it and they're like, oh my God, I don't know what that means. Just pay attention. I'm going to tell you. Okay? So in order to calculate how much you are losing or gaining in BTUs per hour, and this is an energy thing, you are going to take your surface area, which we're going to calculate, multiply it by the difference in the temperatures, which we're going to talk about below, and then divide it by the R value of the window, which is provided. So instead of panicking, just take a deep breath and then go through it. Now, this is given to you. This is all the information you need for that R value part. Since we are in the United States, we are using this column right here. So we are just using the United States R value. You have to figure out what kind of window you have. For this lab, today, this video, I am using this one that's right behind me. I guesstimated the size because I do not have a tape measure with me. I don't know about you. I don't tend to travel with a tape measure. I also didn't even bring my calculator, so I was using the one on my phone, and I'm going to be using the one on the computer just so you can, again, follow along. But you have to figure out which type of window you have. At home, and in the previous examples, I used single pane glass because I live in a house that was built in, I think, the late 1960s. They're single pane windows. My grandparents never replaced the windows, and I haven't been able to afford to replace the windows yet. I have currently just been working with stuff having to do with the roof because we had a hole in our roof recently, and I don't make that kind of money to just re-roof everything, so I'm still dealing with that. Previously was a new refrigerator, which I'll talk about when I get to part 3, and a water heater. Also I mentioned normally with part 3. So I'm having to fix things as they come. Replacing the windows will be one of the best things I can do for my house, but I just can't afford it yet. So when I do the ones at home, I do single pane. Here, I looked at these. I'm betting that it's this, the triple pane high efficiency, but I decided to use the triple pane glass 1/2 inch airspace. Mainly because I wanted to use something different. And I could tell it was triple pane, but yeah, so that's why I use this one. Now, here we go to the calculations. Choose a window nearby, that one. Measure the height and width of the glass surface. That means do not count the border, only the glass. So when I did this, I decided I was going to say mine is 48 inches tall, and I am estimating about 12 inches wide. So there you go. So I just type it right on in. Now calculate the surface area with this formula. So I am just doing this one right here. There. So what I'm going to do is the height times the width. So I just said it was 48 inches tall times 12 inches wide. Whoa, I totally just messed something up there, didn't I? No, I didn't. So 48 times 12. Now I will divide it by 144. That's what it says on the chart here. So 144 equals. That is my surface area. So now, since I know my surface area is 4, I will type in 4 right there. That's my surface area. Now, use table 2 to determine the R value. All right, I've already decided I am using this one as my R value. So you don't have to do it here, but just so I don't forget, I'm just going to do that. That's my R value. Using your thermostat, record the temperature inside the building. Well, I have my little AC thing here set at 70. So there you go. I'm saying 70 degrees. When I was getting all this information, I just checked my phone, and at that moment it was 82 degrees outside. It's actually gone up since then. I cannot believe how bright and how hot it gets so early here. All right, so now calculate the difference of inside versus outside temperatures. Well, that would simply be 82 minus 70, 12. So that means it is a difference of 12 degrees. So there you go. Now, for this, heat loss and gain. It wants the surface area times the difference in temperature. Well, we already know that 12 was my difference in temperature. So if I do times 4, which was my surface area, that gives me a 48. Now, divide that by the R value. Well, right there, there's my R value, the 3.23. So now I go divided by 3.23 equals. All right, so record this data here. So that will be 14.86. All right. So there you go. There is my heat loss / gain in BTU per hour right there. Now, using the formula from step 7, the one we just did, calculate the difference of the rate of heat transfer if your chosen window were to be placed with a window of each different R value. So I'm going to start smallest and go largest. So I am going to do the, what was it? I have to double check again. I already forgot. So surface area times the difference in temperature is 48. So I'm going to write down 48. Okay, so now 48 divided by 0.9, that will be the single pane glass. So that will go here, and I will say 53.33. Okay, now I will do the 48 divided by 2.04. This is the double pane. I wrote down all the ones I needed here. Okay, so this will be 23.53. Since it says 529 and I don't want to keep going forever, I round up because the 9 would bring it up. I hope people remember those rules about rounding. If not, it doesn't make a huge difference, but I like it to be accurate. For me, I mean. So then I do, again, the 48 divided by 3.13, which is the double pane low efficiency. And then this one goes to 15.34. Again, I round it up. And then the final one will be 48 divided by 5, which is the triple pane high efficiency. And that gives me just a 9.6. You can see that the numbers are going down with the better the window quality. Now, Then calculate the difference if the surface area of your selected window was decreased by 50%. Well, my surface area was 4, so half of 4 would be 2. So 2 times 12, which was the temperature difference, gives me 24. Now, I will divide that by, what was it, 3.23, which was my selection for my R value. And that would give me this. So that would be 7.43. The main takeaway for that one is, if my window was smaller, look how much it would have changed. I have just pretty much halved how much energy I've spent on this window. Now calculate the difference if the inside temperature of your window was decreased by 5 degrees. So that means instead of having it be a 12-degree difference, I want it to be a 7-degree difference. So now surface area, right? Yeah, surface area times 7 instead of 12. And then divide that by, I always lose where I wrote that, 3.23. 3.23. There we go. And so that gives me 8.67. So again, if I just simply decided, okay, I'm in Florida, it's friggin' hot out there, I can deal with it being warmer in here, then that would make a difference. There's the message. They're at the beach. Yes, the family is all hanging out down at the beach while I am in here making videos because I can't make them on Saturday like I typically do. So there you go. And I think it's supposed to rain tomorrow, but I'm sure everybody has seen how pale I am. I go out in the sun and I burst into flames. So I actually have hats and stuff. Oh, if you want something funny, totally beside the point, but check this out. Okay. Are you ready? This is me at the beach. I can do that to try to see a little bit more, but I have to stay covered. How goofy is that? I have that, and then I have my Tampa Bay Buccaneers ball cap for just the face, but that one helps with my ears and then can help cover my neck. I forgot my UV protectant shirts that have the long sleeves to protect my arms. And I have my, no joke, 100 SPF sun protectant stuff. The sun hates me. It either hates me and wants to kill me, or it loves me and wants to live in my skin. I haven't decided which, but I like, so I get to go play on the beach when the sun starts to go down. But anyway, beside the point. So here, notice, as is, that's how much is wasted per hour. If I just turned my thermostat up, it would be this. So there you go. All right, now number 9, where it says using your utility bills, blah, blah, blah. This formula here is if you take your actual electric bill and say, like, this past month, holy shnikes, this past month, Norcross, Gwinnett County, it's how they make their money, like seriously. And so the more energy that the entire area uses, the higher the price of your utility bill, your electric bill. It was really hot this past month, and I have fans everywhere. I refuse to even open the curtains. I try to keep all the sun blocked out of the inside of my house as much as possible. I have the sunroom, as you've seen in the other videos, for the cats, and then we can get a little bit of sunlight. But I try to keep as much insulated as possible to keep the inside as cool as possible and run the air conditioning as little as possible. I also have 4 solar panels hooked up. So I know my usage was not a whole lot higher than normal because of all the other parts I have in place. And so when I say this, it makes me worry about the other people in my county. My electric bill was over $300 in 1 month. I do not understand. Like, seriously do not understand. I am going to go through it with a fine-tooth comb later, because unless somebody is sapping out some of my electricity, they really jacked it up for this month, because my typical electric bill is somewhere between 98 and 112. So this more than doubled. There's no reason for that. There you go. But had I used my old electric bill, I would have taken how much they charged, and then I would divide it by how much they said was used. That would tell me how much it costs per unit. That's what this is the unit cost. So for each BTU, how much I paid. However, I am in a different county right now, and I want to show what to do if you don't have an actual bill to use. So what I did is, where this hotel is I have no idea how to say it, Volusia County, Volusia. There you go, that county. And so I just simply looked up what the cost is. They say it is 10.4 cents per unit. So there you go. I didn't have to calculate anything. I just looked it up online. You can totally do this. It's fine. Now, using all that stuff we just figured out, we are now going to fill out this table. Now, we've already talked about a few things here. The surface area. My surface area is 4, so it's going to be 4 all the way down except here. Here, it's reduced by 50%, so I put a 2. Inside temperature. Inside temperature, I said, was 70. So 70, 70, and here, since I have reduced, where it says reduce inside temp by 5, it means reduce the difference, and so this will make it 75. I brought it up. Outside temp, well, it is 82 degrees for every one of these, because I just did all of them together. So there you go. Temperature difference, 12, 12, 12, 7. R value, well, for the low R value, we have 0.9. Whoa, I forgot to put the point in there, didn't I? Yikes, there we go. High R value would be 5. Reduce window surface by 50%. We're using our original R value, which is 3.23, and this number is going to be different depending on what you actually used. Heat loss gain per hour. This is the stuff where I have already calculated it right here. Okay, so for the low R value, this would be 53.3. Did I say 3.3? Yeah, I did. All right, high R value should be 9.6. Yep, 9.6, 9.6. Reduce window surface area by 50%. When I figured that one up, that was 7.43, and then the temperature was 8.67. So all of these are things you calculated at number 7 above. Now here's the one difference here. All of those calculations were per hour. This is now going to be per year. For that, you need to know how many hours there are per year. There are, well, I'm going to just put it right here. I'm going to say 8,760 hours per year. Now, obviously, if there's a leap year, you add 24 to that. I'm not going to worry about that. I'm just keeping it here. So now you just take that number and multiply it by 8760. So 53.33 times 8760. All right, so that will be 467,170.8. Now, same thing here. Where are we? Okay, so I messed up a couple of calculations and clipped a small portion out and decided this is what I was going to do. You can do it however you want. I'm going to show you both ways real quick. but I think this one might be a little easier for me. The main thing to notice is this is talking about BTU, okay? Our billing is on kilowatts per hour. Down here is how you convert BTU to kilowatts per hour. So what I am going to do is I am going to take this BTU, which is, 53.33. I am going to go ahead and convert it now to this. So divided by 3412. It's a very small number. I am well aware of that. And now I am going to take that and multiply it by 8,760 hours per year. So times 8,760. And so that is going to give me a total of 136.92 kilowatts per hour. All right, so now that I have this number, I am going to multiply it by how much the electric company charges per kilowatt hour. So times 10.4. So this number right here will be 1423.97. It's so funny because it's slightly off from what I did before, so I must have accidentally punched the wrong thing in. And considering you've seen how many times I punch a wrong number in, you'll know why I wish I had my actual calculator. Okay, so this is how many cents per year is being spent on this one window. So now I am going to redo these in order to match properly. Kilowatts per hour, and then times 10.4. Notice how the price is going down and down and down, which is good. Okay, last one, 8.67 divided by 3412 equals times 8760. There we go. This is 22.26. And then this will be times 10.4, kerbam. And that is 231 point, well, see, 498 is going to bring it up to a 50. Because the 8 will bring the 9 up to a 0 and carry the 1. So there you go. So that is how you fill out this table. Now, where do we go from here? Well, oh, that's the last spot where I actually wrote my own personal notes. So now what you're going to do from here is you're going to do some averages. You want to see what this means over the course of an entire year. So here we go. Main thing to note is that not all months have the same number of hours because we have 28, 30, 31. And again, that 28 sometimes has 29. Did this year have a leap year? I kind of think it did. I wonder if that means people will start getting panicky later. Anyway, so fill out table 4 below. When finished, record the total number of degrees above or below 65 right here. Okay, so this is just an example. This is showing you what it is. So it's showing you for each month, like January, February, you're going to say what is the mean monthly temperature, compare it to 65 degrees, and then your difference times how many hours are in that month, and then the total. So first you need to get your mean monthly temperature. Since I'm doing this for here, for Volusia, however you say it, I just Googled it. I looked up the county and their mean times. I don't mean times, I mean temperatures. And Some people get really nitpicky and they do what's in between these. I just do it by the high. It's easier for me. So for this, let me close these others. I am going to do this because it's easier for me this way. So now I can just say 68, 71, 74, 79, 83, 87, 89, 89, 86, 82, 75, and 72. So there are some averages. Now, for every one of these, I am going to put the same number here. So 68. Okay, so here I have now done the entire mean monthly stuff from here that I got from online. Then I put them all here. Now the big thing to remember is we want absolute value, because some of these, well, this is Florida. Every one of these is going to be a negative number. We don't want to carry over the negative, so we are just going to put it as just the whole number. So 65 minus 68, if you calculate, it's going to say -3. We just want a 3. It's going to be like that. So I'm going to do this for every single one of these all the way down. If you're not sure and you want to calculate, seriously, just do this. Use your nifty little calculator and say 65 minus 71. Again, notice it says -6. You just type 6. You're going to do this all the way down, and then I'll show you what we do after that. Okay, so now we have all of those. So we have your mean monthly temperature. We have it subtracted here. We have all only positive numbers, even though every one of these would have been a negative. We just want the positives. Now we multiply it by the number of hours. Yikes, the number of hours per month. I'm just trying to see something. Okay, yeah. So this one is calculated for a 28-day February. All right, so now you're just going to do 3 times 744. So 3 times 744. Yes, I'm using my phone right now. You have 2, 2, 3, 2. Then you do the same thing here, but here I will have 6 times 672. So 4032, and you are just going to do this all the way down the board. Okay, now that I have all of these calculated, which again is just taking the mean monthly temperature, seeing what the difference is between 65 and that, which was the number 3 here, multiplying it by the number of hours in a month. That gives me the total degrees above or below 65 degrees for that month. I then add all of these together. So after I add every one of those together, I have 128,160. So that is my total. Okay, so the question was, when finished, record the total number of degrees above or below. So that would be what I just calculated, 128,160. And I know I don't have to delete the extra lines, I just do. Now, when you're done, if you're curious as to what this means, this is totally extra. So, your surface area plus your total degrees and your R value. For me, if you remember, this one was my 4 times 12 and then divided by 3.23. Okay, so that gave me originally 14.86. There we go. Surface area, total degrees. Oh, wait, no. No. My apologies, people. It would be these degrees. Wow, I was just making it so much smaller. And then I still copy and paste the wrong thing. 1, 2, 8, 3.160. So that means that times 4 and then divided by 3.23 would be a 158,712.074. And yes, I know I just did this instead of that. It's just easier. But if you want to see what it was, I just did 4 times, and the number I did 128,160 equals, and then divide it by 3.23, which is this window, which gives me that number. Okay, now convert it. So convert this giant number right here. Copy. Paste, because I like copy and paste. We are now going to take this number and divide it by 3.412 to convert it to our kilowatts per hour, which will give us 46.52. Now we will multiply that, the 46.52, times the 10.4 that the electric company here charges. And so that will give us 483.76 per year. That's costing per year for one of these windows. And the fact that this is a hotel, I'm on the 7th floor, and I don't know how many rooms total there are, but there's a lot. And if you look, I don't know if you can tell, that's just one window. There's another one there and another one there, and this is technically a sliding glass door, but that equates to a lot, just so you know. Okay, so that is how you do energy consumption 1, which now brings me to the heating water. This one, so much easier, so fast. This one, you're basically just going to put something in the sink and you're going to turn it on and have it drip, 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 just 1 drop per second. Time it for 15 minutes and then weigh it. I have a kitchen scale, and so I would take, say, I could take a bowl like this. Whoa, I'm sliding. I could take a bowl like this, put it on the scale, and hit the button, and it will either say tare or 0, but you do that so then it weighs what your bowl weighs. Or you can just do that, weigh your bowl, and write the number down. Put that under there, collect the water for 15 minutes, and then weigh it again. That way you can see how much water you just did. When I did this previously, I remember it was 0.53. So there you go. So it was like just a little more than half a pound. Now, multiply the pounds of captured water by this much. So I am going to say 0.53 times 35040 equals, and that means 18,571.2 pounds per year, because that is how many, the 35,040 is how many 15-minute periods there are in a year, apparently. I never thought about it, but I guess so. So I now have this. Now multiply this number by 80, which is the temperature difference of water when it enters the water heater and when it leaves. So take this times 80, which will give me 1485696. So that is BTUs. We've already done this whole conversion for BTUs a while ago, so I am just doing that. If you use natural gas, it's a different thing. I'm just using this because I didn't look up how much natural gas costs in this county. So I'm just being cheesy. So now I take this number, which I just calculated, divide it by 3414, bam. Now this number goes right here, which is 435.18. So this is what I'm saying is how much it's costing energy-wise for a drippy faucet in a year. So it says record this on table 5. Table 5. Well, I've actually already converted it, so I'm putting it there. So that was faulty of where it should go. I need to fix that. That's what I need to do. I'm going to say on table 6. There we go. Because this is actually what I should be putting in to table 5. So I am going to do that. I'm going to take this and actually put it to look at me thinking. Oh, all of this is what we just did. Okay. Interesting. I don't think we even need table 5. We don't, because look, that's what we've already just done. So this is actually what they had us put here. So that would actually go right there. And times 80 is this one. So this is all the stuff we already filled out. Interesting. Okay, so we said we used, this was the BTA used, divided by 3414, which we already did. So this gives me my, I don't need all those blanks. There we go. Now multiply it by 10.4. For this county, you have to pick out yours. And that means it will cost, so times 10.4. So the drippy faucet, 4525.84. There you go. Per year. That's how much is getting wasted in energy and cost for that. That means I need to take a better look at my faucets, because it looks like that's going to be worse for me than my windows. Crazy, huh? All right, so that is energy consumption 1, redone from scratch as of this morning and on here, so you can see how long it takes. And hopefully I answered all your questions. I did small editing, and I am about to just go blah in order to remind myself where this one ends, because it occurs to me it might be easier to do 3 separate videos, even if the others are way shorter, because part 1 is the one that takes the longest. So if you're watching them all the same day, see you in just a moment.